Hi everyone, welcome back to the lecture series of video lecture series of Theory of Automata and Formal Languages. Topic is context-free grammar, and we are into part number 5. So in this part of the video lecture, we will be covering the different types of regular grammar, the different types of derivation tree or parse tree, and also we will work with an example of how to convert a grammar to a finite automata. Basically, we'll be dealing with a conversion of a grammar to NFA, but we will check how to process. So let's start off with the first topic where we are going to deal with the types of regular grammar. If I talk about actually the title of this particular topic is not actually types of regular grammar. I'll be discussing two important topics. One is linear grammar and the other one is derivations. In those two topics, that is linear grammar and derivations, you will be coming across the types of it. Okay, so let us check the first point that is already mentioned over here, linear grammar. So linear grammar is actually you can say a grammar only, but is of the form alpha tends to beta. Okay, because as we are talking about grammar, we are dealing with production rules. Everything is dependent on the production rules, correct? So linear grammar is having a production rule of the form alpha tends to beta, where alpha is, I have already mentioned over here, where alpha is exactly one non-terminal and it must exist, and beta must have at most one non-terminal in the production. Okay, this is the general description of a linear grammar. But if I talk about the types, this is one kind of question that you can expect. Is number one is left linear grammar, number two is middle linear grammar, and number three is right linear grammar. Okay. So if I have already mentioned an example of for all these three categories. First one is your, as I told you, is your left linear grammar, where S is the start, is one particular non-terminal which is having a production S01. That means if we are talking about alpha tends to beta, the alpha, that is the non-terminal, should be in the left-hand side of the grammar of the production. Then it is called as left linear grammar. Okay, that means S01, S0, 1, 2, 3, 4, suppose, then S0, S01, S0, S01, 01, 01, like this, or simply S0. That means the non-terminal with which the production is being defined should be at the left-hand side. That's it. So if that particular non-terminal is in the middle of the production, then it is called as middle linear grammar. As you can see here, I have marked as dash. Okay, and if on the right hand side of the production that particular non-terminal is present, then that is known as your right linear grammar. Clear? So this is a small definition for left linear, right linear, and middle linear grammar. But the question arises is that what we are discussing is about regular grammar. So I have mentioned a point where a regular grammar is either a left linear or a right linear. Always keep in mind, but not both. So this is also a definition of a regular grammar in terms of linear grammar. Got it? So you can mark as a one kind of definition note. Okay, and finally I can mention that one point that I can mention is that a regular grammar is a linear grammar, but a linear grammar is not always a regular grammar. So if you check the definition with, as I've already mentioned in all these videos, if you are preparing some kind of notes and you are writing down those definitions, then you can compare those definitions. Where I have already told you what is the definition of a regular grammar, what is the definition of a context-free grammar, what is the definition of a regular grammar in terms of linear grammar that we have discussed over here. Okay, so this is one point that we have discussed is about linear grammar. Now next point, as I have told you, we will be discussing in terms of derivations. Now if I talk about derivations, we will be talking about two types. Derivations means we are deriving a particular string from the grammar, correct? So this kind of derivation is dependent on two types. One is leftmost derivation, otherwise rightmost derivation. So actually this topic already I have covered in the previous lecture. If when we are generating a particular string while we are discussing about ambiguous property, okay? So if anyone has skipped this particular topic, you can check in my previous video lecture where I have discussed about ambiguous grammar, and there I have mentioned clearly the working process of leftmost derivation and rightmost derivation. But don't worry, we will also discuss in this video lecture with an example, okay? So let us check what is in the next topic. Okay, now this is what you can say. I have prepared a definition for leftmost derivation and rightmost derivation. I don't want to describe this. I want to directly jump off to an example where you can understand how this has been carried forward. Okay, so you can pause the video. You can note down the definition. Okay, as if you're attempting for any university exam paper, definitely these definitions will be a helpful one. Okay, so I'm just notifying you a particular point is that in leftmost derivation, generally some way or the other, we generally notify with the help of this. Okay, and if for one or more number of steps, then we generally notify by this one over asterisk. Okay, same goes with the definition for rightmost derivation. Okay, now what is the meaning of this leftmost and rightmost derivation? Let us take an example and we will try to solve it out. Okay, so I have taken an example. This is question number where I have taken a grammar having these production rules. Okay, so what I have to do is that perform the derivation of the string b b a b a b a by using leftmost and rightmost derivation. So the students who have already seen my previous video lecture on ambiguous grammar, there I have already mentioned about leftmost and rightmost derivation. So if the student are aware of it, then you can pause the video and you can at least attempt once. Okay, but don't worry, I will explain to you how it is working. Okay, let me take a rough page. Okay, let me write down the particular video problem. So the problem says S stands to BB, AA, A tends to small letter b, small letter bs, small letter a, capital letter A, capital letter A. Then B, capital letter B tends to A, small letter as, small letter b, capital letter B, capital letter B. So these are the productions that I am having right now, and I have to derive the string B, B, A, B, A, B, A. Okay, now what is the first string? B, correct? Definitely which production? You have to start off with the starting production only. What is the starting production? S is the starting symbol. Okay, so S is the starting symbol and S is having the production B, B and AA. So you can take any of these two. But as the initial string is capital small letter b, so I'll be taking this production. So let me write in this fashion. S stands to B, B. So what I'm doing leftmost derivation. Okay. Now as we are having only one non-terminal, and that too also if you're having only one non-terminal, then you no need to worry which is the position of it. Either it may be in the left side, either it will be in right hand side. So you have to just eliminate that. So I have to eliminate this B. Okay, as I am doing one or more number of steps, I can put it as star. Depends on you. It's not mandatory. So next, what this is done. Okay, now what next symbol? Again B. So for capital letter B, I have to take a production that is having small letter b. So this is the production. So B, B, capital letter B, capital letter B. Done. Now we are done with these two B. Now the next alphabet comes is your symbol comes is your small letter A. So which leftmost derivation, as you're doing leftmost derivation, which non-terminal you have to eliminate? The leftmost one, correct? Now as we do the same process, lm, okay, now it depends that this B is having two productions. One is A, one is having AS. So it depends on you which you want to carry forward. Suppose I am taking for this production as small letter A. So BB, small letter A and capital letter B. Okay, then this is again I'm carrying forward. Now you are left out with only one B, so no need to worry. So I have to replace it with AS. So definitely B, B, A, S. Again you are left out with one more. Okay, so what we have to do? Again we have to do the same process. Now again these two A's are done. Now again the B comes. So for S I have to take the production BS. So B, B, A, B, S. Correct? Now I have done with this. Okay, now I am next symbol is capital small letter A. Now for S, which one you are going to take the production? This one. So I have to replace it by LM. So B, B, A, B, S by A, capital letter A. Done. Now you were done with this one. Only you are left with small letter B and small letter A. First comes is your small letter B. So I have to replace this by small letter, capital letter A. Okay. Now B, B, A, B, A. Now for capital letter A, which production you are going to use? You are going to use BS. So I can write BS. Why I am doing BS? Because one more symbol is left out, that is small letter A. Correct? For that, I have to replace it by which one? B, B, A, B, A. And for S, I can use which symbol? For S, I have to use which production? A, capital letter A. Now, as you can check it out, sorry, I made a mistake. One more string is left out. That is your B. I forgot to mention in the question. Okay. Let me mention. I have mentioned in the question. So you can also correct it. I have one more B is left out. Okay. Now, as we can check it out, last symbol that is left out with capital letter A is having this symbol, that is B, B, A, B, A, B, A, B. That's it. So this is how you are going to find out the leftmost derivation process. Okay, is this clear? So first you have to cross verify every string that you are having, and then you have to eliminate the leftmost non-terminal symbol with the correct production. Okay, if you're having only one non-terminal in the production in the string, then no need to worry. You can replace by any of the production that depend on the value or that depend on the string. Correct? So you can pause the video and again you can check it out how I performed. So from starting symbol, you have to take the starting production and you have to select which is the first initial string value. Suppose B is the initial value, definitely I have to take the production S tends to B, capital letter B. Correct? If A was there, then I have to take the production as A. Then you proceed one after another based on the sequence of your string, and until you find out the value. Sometimes they might ask you whether that the grammar will be given to you, and they will ask that this particular string is being derived or not, or is being verified or not, or is being generated or not. Okay, by either using leftmost or rightmost derivation. So I am keeping the rightmost derivation on your side. You can do on your own. The same process you have to do. You have to, suppose I have done here, I have no option. I have to eliminate only capital letter B. So I can remove by this process. Now here you have to remove in terms of this left hand side, you have to remove this right hand side for rightmost derivation. Okay, just keep in mind and just check whether that particular string is being derived or not. So this is one kind of assignment to you. You try on your own and definitely you will be getting the answer of this particular question. Okay. So this is your first topic where we have studied about the types of grammar in types of regular grammar in terms of linear grammar and in terms of derivations. In terms of linear grammar, you have understood the left linear grammar, right linear grammar, and middle linear grammar, where you can where you have understood that a regular grammar can be either a left linear or a right linear, but cannot be both. And you have learned about derivations where you have where you have understood the two types of derivation of a string. One is your leftmost derivation, other one is your rightmost derivation. Clear? So we will be jumping off to the next topic, where you are going to learn a derivation tree. Okay, so this is an important topic. We have already discussed about this in possibly in the third part. Yes, in the third part of our video lecture series, where I have explained to you what is mean by parse tree, what is the definition of a derivation tree, both are same, and how I have taken a grammar and I have derived a particular parse tree. Okay, now here I was just want to explain to you the types of this. You can also note it down. This another name is parse tree, I have already mentioned. So derivation tree is an ordered rooted tree where the root vertex is always the start symbol. Then all the non-terminal symbols are being represented by are encircled with a circular shape. Correct? Then just need to know that where graphically represents the semantic information of strings derived from a CFG. So this is a definition of derivation tree. We have already discussed. We will jump off to the types of derivation tree. The two types of derivation tree is left derivation tree and right derivation tree. Okay. And for your kind information, this topic is also being done in your part number 4, where we have learned about ambiguous grammar. In ambiguous grammar, I have explained to you how to use leftmost derivation technique, and then you have to draw the derivation tree. That leftmost derivation technique, from the leftmost derivation technique that you have drawn the derivation tree is nothing but your left derivation tree. Same goes with the rightmost derivation technique. Okay, but let me give you an example. It is defined. The definition is that it is obtained by applying production to the leftmost variable in each step, which we just now we have understood in the leftmost derivation technique. Okay, and right derivation technique, the right derivation tree is nothing but in which it is obtained by applying productions to the rightmost variable in the each step. Okay, so this is the definition. For example, I have taken and this one for generating a string a plus a into a from the grammar e implies e plus e asterisk e and a. So I have also defined you with an example. So this is an example. So if we talk about leftmost derivation, first I have taken for e the root node is always the start symbol. So e is the start symbol. So I have taken the root node as the start symbol. Then I have taken the first production, e plus e. Correct? Now in this particular production, if you are drawing a leftmost derivation tree or left derivation tree, you have to keep in mind that while in your writing in your examination paper, okay, so you have to note it down in the separate bracket in your right hand side that which production you are using for which, or you can mention at the last that first I have used e tends to a, then I have used e tends to e asterisk e, then e tends to a, then finally e tends to a. So these kind of productions you can mention once you have drawn the parse tree. Okay, this is actually one kind of way of writing in your examination. Okay, now as I have told you, this is the string that you have finally received. This is nothing but a plus a asterisk a. Similarly, for the rightmost derivation, I have taken e asterisk e. First I will eliminate this e by a, then I will eliminate this e by e plus e, and in this process I will eliminate e by a and finally e by a, because I am doing from the right hand side to the left hand side. And in the left derivation tree, I have done first e plus e. First I will eliminate e tends by a, then I will eliminate e by e asterisk e, And then first eliminate, I will eliminate this E by small letter a, and then finally this one. That means left hand side till right hand side. That's it. Right hand side till left hand side. This is just a brief description of left derivation tree and right derivation tree. So generally how question comes? Question generally comes for the string, for generating a string, this one, from the grammar does perform leftmost derivation tree or right derivation tree. That's it. And last, I want to just add one point, that I have already discussed ambiguous grammar. So if I ask you a question that whether this string is or whether this grammar is an ambiguous grammar or not, yes, it is an ambiguous grammar. Why? Because for this particular string, we are having two different syntax tree or two different parse tree. Okay. So this is the definition of derivation tree, where we have understood what is the definition of derivation tree along with its types, and what are the types: left derivation tree and right derivation tree. And we have seen two examples for this. Okay. So last but not the least, I'll be talking one more topic, and that topic is very useful from competitive exams point of view, where generally questions ask as conversion of grammar to a finite automata. Okay, I will discuss how to convert this. It's a very simple one. Okay, I am having the productions over here. I will move a little bit fast. Okay, I'm having the productions over here. I have to draw a particular finite automata from this. Okay, so finite automata, as we know, the start symbol is what? Capital letter S. Definitely the start symbol is capital letter S, and it will also be the initial state. So S I have drawn over here, and I have drawn the initial state. Now from S you can see terminal symbol A is moving to capital letter A. That means A will be one state. So it will be like this, as simple as that. And from S I am moving small letter b to capital letter B. That's it. This is how you need to identify a grammar. Any doubt? It's very simple. Like, okay, now what we have to do is that I have to check the left out productions. So from capital letter B, small a is being transferred to A, capital letter A. So I will be drawing like this. From B, A is being transferred to capital letter A. And from B, B is being transferred. Okay, now the question arises, where this B will be gone? This is already accepted, right? For capital letter B, small letter b is having a production. That means this is an accepting one. So I have to use one more state. Suppose I'm writing as F, and this is your final state. So from B, this will be going like this.